This video is on topic 46, magnets, magnetic field lines, and solenoids. Question 1. List some differences between the electric force and the magnetic force. A stationary particle can feel an electric field and therefore an electric force. A stationary particle cannot feel a magnetic field and therefore it cannot feel a magnetic force. The electric field and therefore the electric force can make a charged object speed up or slow down or change direction. The magnetic field and therefore the magnetic force can make a moving charged object change direction only. The magnetic field and therefore the magnetic force cannot make a charged object speed up or slow down. Question 2. What are two situations in which magnetic fields are observed? A permanent magnet and a moving charge. Question 3. List some metals which have magnetic properties. Iron, nickel, cobalt, and gadolinium and dysprosium. Question 4. Define hard magnet. Define soft magnet. A hard magnet is a magnet which is difficult to magnetize and difficult to demagnetize. A soft magnet is a magnet which is easy to magnetize and easy to demagnetize. Question 5. How can you demagnetize a magnet? Heat it up or drop it down really hard. Question 6. Give some rules for drawing magnetic field lines. Magnetic field lines always point from North Pole to South Pole. They always loop, they never cross. They are not always perpendicular to the surface of a magnet. More magnetic field lines mean a stronger magnetic force, and magnetic field lines are strongest at the poles. Question 7. For each figure, draw 6 magnetic field lines with arrows. So you could see magnetic field lines always point from north to south, and they never cross. Question 8. Draw and label the Earth's magnetic North Pole, magnetic South Pole, geographic North Pole, and geographic South Pole. Draw 4 magnetic field lines with arrows. So as you can see, the magnetic north is on the South Pole, the geographic south. And the magnetic south is in the geographic north. And I only drew 2 magnetic field lines with arrows. Should have drawn 4. Question 9. What are some differences between magnetic field lines and electric field lines? There are magnetic field lines inside the magnet. There are no electric field lines inside a charged conductor. A magnetic field is strongest inside the magnet and near the poles. A charged conductor has its excess electric charge on its surface. That excess charge is evenly distributed on the surface. You can isolate a positive charge from a negative charge. You can isolate a negative charge from a negative charge. You cannot isolate a North Pole from a South Pole, and you cannot isolate a South Pole from a North Pole. Question 10. What is a magnetic monopole? Where in the universe can we find a magnetic monopole? A magnetic monopole is either a North Pole or a South Pole found isolated by itself. Magnetic monopoles have never been found in nature, and they've never been made artificially in a lab. If they are found or discovered, then Maxwell's equations will have to be changed, and that's big. Question 11. Draw the symbols for an axis going into the page and out of the page. We can draw an axis to the left, right, up, and down on a paper. It's difficult to draw an axis into the paper and out of the paper. So imagine looking at an arrow. If the arrow is moving towards you, then you see a dot. If the arrow is moving away from you, then you see the feathers of the arrow. So if you want to draw something that's going into the page, put an X and then a circle around it. If you want to draw something going out of the page, like towards you, put a dot and a circle around it. Question 12. Draw magnetic field lines for each current carrying charge. So first, place your right thumb in the direction of the current, then grab the wire with your right fingers. Your fingers go into the page on one side of the wire and out of the page on the other side of the wire. The number of into the page symbols must equal the number of out of the page symbols, since magnetic field lines loop. And you could see the direction of electron flow is going to be opposite that to the direction of current flow, because current is the flow of positive charge. Question 13. Describe and draw a solenoid. Use the right-hand rule to draw magnetic field lines and the poles. So solenoid is a loop of wires which creates a magnet similar to a bar magnet. So you don't need to buy a magnet, you just need to buy a battery and a wire, and you can loop the wire. So place your fingers in the direction of the current in the loop of the wire, and your thumb is in the direction of the North Pole. So if your thumb is in the direction of, if your fingers are in the direction of the current, then you can see the North Pole is facing up and the South Pole is down in this image, and those red lines are magnetic field lines. Question 14, state 3 ways we can increase the magnetic field inside a solenoid. We could increase the current in the wire, increase the number of loops per length of wire, or insert an iron core between the solenoid. Question 15, draw magnetic field lines in a circular current carrying loop. Okay. So place your right thumb in the direction of the current. Your fingers will point into the page and out of the page. So you have to grab the wire. And there must be an equal number of dots pointing into the page as there are pointing out of the page, since the magnetic field lines always loop. So you can see on the bottom left here, my thumb is in the direction of current and I grab the wire. So my fingers go into the page outside of the wire, of the loop, and they go out of the page inside the loop.